Have you ever wondered why some places on Earth freeze below minus 50 degrees Celsius, while other places stay warm all year long? Why does Antarctica feel like another planet, while regions near the equator feel like summer every single day? The answer is not just one reason. It's a combination of science, geography, and how our planet receives energy from the sun. Today, let's break it down in a simple way. Earth may look uniform from space, but its temperature changes dramatically from place to place. Some regions experience extreme cold warnings, while others never see snow at all. So what controls temperature on Earth? Let's start with the most important factor of all. The biggest reason some places are colder than others is latitude. The Earth is round, not flat. Because of this shape, sunlight does not hit all parts of Earth equally. Near the equator, sunlight hits the surface directly. This concentrated sunlight delivers more energy, making these regions warm throughout the year. But near the North and South poles, sunlight arrives at a slanted angle. The same amount of solar energy is spread over a much larger area. Less energy means less heat. That's why places closer to the poles are much colder than places near the equator, even though the sun is the same. Now let's talk about altitude. As we go higher above sea level, the air becomes thinner. Thin air cannot hold heat very well. On average, temperature drops by about 6.5 degrees Celsius for every 1,000 meters of elevation. That's why hill stations and mountain regions are cold, even when nearby low-lying areas are hot. For example, a city at sea level may experience summer heat, while a nearby mountain town remains cool or even cold. This is also why snow exists on mountain peaks close to the equator. Another major factor is how close a place is to the ocean. Water heats up slowly and cools down slowly. Because of this, oceans act like giant temperature regulators. Coastal regions stay relatively moderate, not too hot in summer and not too cold in winter. But inland areas, far from oceans, experience extreme temperatures. They heat up quickly in summer and lose heat rapidly in winter. That's why continental interiors, like Siberia, experience some of the coldest temperatures on Earth. Oceans don't just sit still, they move heat around the planet using ocean currents. Warm ocean currents carry heat from the equator toward higher latitudes. Cold currents move cold water toward warmer regions. For example, Western Europe stays much warmer than other regions at the same latitude because of warm ocean currents. On the other hand, cold currents can make coastal regions surprisingly cold and dry. These invisible rivers of water play a huge role in deciding regional climate. Now let's talk about snow and ice. Snow and ice reflect sunlight back into space instead of absorbing it. This is called the albedo effect. When sunlight hits ice, most of the energy is reflected away, so the surface remains cold. This creates a feedback loop. Cold areas stay cold, ice remains frozen, and temperatures remain low. This is one of the main reasons Antarctica is the coldest place on Earth. Wind also plays an important role. Strong winds remove heat from the surface quickly, making temperatures feel much colder than they actually are. This is known as the wind chill effect. Cold air is heavier and sinks, while warm air rises. In polar regions, high-pressure systems trap cold air near the surface, allowing freezing temperatures to persist for long periods. This is why cold waves can last for days or even weeks. Antarctica combines all these factors: high latitude, high altitude, thick ice cover, strong winds, and isolation from warm oceans. That's why it's colder than the Arctic, even though both are near the poles. Meanwhile, deserts near the equator receive intense sunlight and have dry air, making them some of the hottest places on Earth. So, Earth's temperature is shaped by many factors working together: latitude, altitude, oceans, wind, and ice. That's why our planet has freezing cold regions and tropical heat at the same time. If you enjoyed this simple science explanation, like the video, subscribe to the channel, and let us know what topic you'd like explained next. Stay curious and stay warm.